Welcome to the FPV Kamikaze drone data card video. In the last video we covered the Switchblades 600, a $6,000 precision loitering munition with a javelin-derived anti-tank warhead and 40-kilometer range. Before that we covered the Lancet 3, a $35,000 to $50,000 Russian precision loitering munition with a shaped charge warhead and sophisticated EO guidance. Today we cover the weapon that has made both of those platforms look expensive. The FPV Kamikaze drone. $300 to $800. 5 to 15 kilometer range. Improvised warhead. Hundreds of thousands deployed. And it is destroying tanks, artillery, vehicles, personnel, and fortifications on both sides of the front line in Ukraine every single day. This is not a sophisticated weapon system. It was not designed by a defense contractor. It was not procured through a government acquisition process. It is a commercial racing drone airframe, the same kind of platform that hobbyists fly through obstacle courses for sport, fitted with an RPG grenade, an anti-tank round, or a shaped charge, and flown by an operator wearing FPV goggles who guides it into the target in real time. The entire system costs less than a tank round. And it is killing tanks. FPV stands for first-person view. The operator wears a headset that displays the live video feed from the drone's forward-facing camera. They fly the drone as if they are sitting in the cockpit, a completely immersive real-time visual control experience. That operator skill is the entire guidance system. There is no GPS lock. There is no autonomous seeker. There is no terminal guidance algorithm. There is a human being wearing goggles, hands on a controller, flying a $300 airframe into a target at 100 kilometers per hour. Let's look at the physical description. The typical FPV Kamikaze is a quadcopter, 4 rotors. Compact, maneuverable, fast. Airframe is carbon fiber and plastic composite, commercial racing drone construction. Total weight including warhead is typically 1 to 3 kilograms. Wingspan varies from 20 to 40 centimeters on the typical combat configuration. Electric motors powered by LiPo battery packs. Maximum speed 70 to 100 kilometers per hour in standard configuration. Racing FPV builds can push 140 kilometers per hour or beyond. Range is 5 to 15 kilometers, limited by the RF control link and the battery capacity. Flight time is typically 5 to 15 minutes depending on battery load and speed. The warhead is whatever is available. RPG-7 grenades are the most common, a shaped charge designed to penetrate armor. Anti-tank rounds from rifle-launched grenade systems. Shaped charges fabricated locally from available explosives. The warhead is attached to the front of the drone and detonates on impact. Penetration capability depends entirely on the warhead chosen. With a proper shaped charge, the FPV Kamikaze can penetrate light armor, damage main battle tanks through top and rear attack where armor is thinnest, destroy artillery pieces, and devastate unarmored vehicles and personnel. Cost: $300 to $800 for the complete system including warhead. That is the number that defines this weapon's strategic significance. $300. Against a tank worth $3 million. Against an artillery piece worth $200,000. Against a soldier whose training and equipment represents an enormous national investment. The cost-exchange ratio at the low end is 10,000 to 1 in the attacker's favor. That number is not a rounding error. It is a strategic reality that is rewriting the economics of land warfare in real time. Ukraine has produced and deployed FPV Kamikaze drones by the hundreds of thousands. Russia has responded in kind. By 2024, both sides were producing tens of thousands of FPV Kamikazes per month. Ukrainian volunteer workshops, commercial drone companies, and military production facilities all contribute to an output that dwarfs anything achieved by conventional weapons procurement. Operators train in weeks rather than years. Airframes are assembled from globally available commercial components. The supply chain is the global hobby drone market, and it has proven more resilient and scalable than any government weapons program. Ukraine's industrial innovation in the FPV domain has been extraordinary. When Russia began jamming the control frequencies being used, Ukrainian operators and engineers switched frequencies, changed communication protocols, and in some cases moved to fiber-optic control links, a physical cable that pays out behind the drone as it flies, providing a jam-proof control channel that electronic warfare systems cannot touch. That adaptation from RF to fiber-optic control happened in weeks. Not months. Not years. Weeks. The engineering feedback loop between the front line and the production workshops is the fastest in the history of weapons development. The fiber-optic FPV is worth its own moment because it changes the countermeasure profile fundamentally. A standard RF-controlled FPV can be jammed, interrupt the control signal, and the drone loses its guidance. A fiber-optic FPV cannot be jammed. The control link is a physical cable. No electromagnetic attack defeats a wire. The drone also cannot be spoofed, cannot be hijacked, and cannot be redirected by any electronic means. The only way to stop a fiber-optic FPV kamikaze is to physically intercept the drone or destroy the operator, and the cable spool limits range to however much fiber is on the reel, typically 1 to 3 kilometers for current systems. Now the countermeasure vulnerability profile, and I want to be honest here that this data card covers a class of weapon rather than a specific manufactured system, so some of these ratings reflect the typical RF-controlled variant with notes on how fiber-optic changes the picture. RF jamming, high for standard RF variant. The FPV control link is the primary vulnerability. Interrupt the signal and the drone either crashes, flies straight until battery exhaustion, or returns to a fail-safe hover. Russian electronic warfare systems have been specifically optimized to jam FPV control frequencies. Ukrainian operators responded by frequency hopping and eventually by moving to fiber-optic control. Very low for fiber-optic variant, no. RF link to jam. GPS spoofing, low. Standard FPV kamikazes do not use GPS for guidance. The operator guides visually in real time. There is no GPS lock to spoof. GPS spoofing is simply irrelevant against this platform, which is one of the reasons it has been so effective in heavily jammed environments where GPS-dependent systems fail. EMI and EMC attack, high for standard variant. Commercial electronics with no hardening whatsoever. Flight controller, ESC motor controllers, FPV camera, video transmitter, all consumer-grade components with no EMI shielding. A directed microwave or EMP attack that disabled the electronics would crash the drone immediately. Moderate for hardened variants. Ukrainian manufacturers have developed domestically produced FPV systems with improved EMI resistance specifically in response to Russian electronic warfare pressure. Microwave attack, high. Same reasoning as EMI, unhardened commercial electronics. The compact airframe means all vulnerable components are packed closely together with minimal shielding. Laser-directed energy weapons, moderate. Small cross-section. Fast in attack profile. Difficult to track and maintain dwell time on a maneuvering target. However, the relatively slow loiter speed and the predictable approach geometry during the terminal attack make laser engagement possible for capable systems. At 500 to 800 meters the laser engagement window opens. Below 300 meters the closing speed makes dwell time insufficient for most current systems. Kinetic intercept, moderate to high. Small target. Fast. Low radar cross-section, commercial composite and plastic construction returns almost nothing on most radar systems. Visual detection is the primary detection method. Ukrainian soldiers and Russian soldiers alike have used shotguns, rifles, and even nets to engage FPV drones in the final meters of approach. Dedicated counter-UAS gun systems have proven effective. But the sheer volume of simultaneous FPV attacks makes kinetic intercept a magazine depth problem. You can kill individual drones, but you cannot kill them all simultaneously when they come in swarms. Net and physical capture, low to moderate. Too fast and too maneuverable for most net systems in the terminal attack profile. Some success with net-equipped interceptor drones engaging FPV kamikazes before they reach terminal attack geometry. Cyber attack, low for standard variant. Simple commercial flight controller with no network connectivity. Nothing sophisticated to hack. Moderate for more advanced variants with network features. Cope cage, partially effective. Ukrainian and Russian armor crews began fitting wire mesh cages around vehicle turrets and top surfaces, the same cope cage countermeasure used against Lancet attacks. Against an FPV carrying an RPG grenade fused for impact detonation, the cage can trigger the warhead before it reaches the armor surface, reducing penetration. Against an FPV fitted with a delay fuse or a shaped charge designed for standoff detonation, the cage is less effective. Both sides are iterating on warhead configuration versus cage design in real time. Overall vulnerability rating, high for standard RF-controlled variant. Moderate for fiber-optic variant. The primary vulnerabilities are the RF control link and the unhardened commercial electronics. The fiber-optic modification addresses the most critical vulnerability. The EMI and microwave vulnerabilities remain regardless of the control link architecture. Now the convergence argument, and the FPV Kamikaze makes it from the most unexpected direction in this entire series. Every other platform we have covered began with some level of designed military capability and converged toward the drone specification. The JASSM is a cruise missile. The Switchblade is a purpose-built loitering munition. The Lancet is a designed weapon system. The FPV Kamikaze began as a sport. It began as a hobby. Commercial racing drone pilots developed the airframe, the motors, the controllers, the goggles, the video systems, all for the pleasure of flying fast through obstacle courses. Military adoption of this technology did not require any re-engineering of the fundamental platform. It required strapping a grenade to the front. That is the convergence thesis at its most extreme. The commercial hobby drone industry, optimizing for speed and agility and pilot experience, inadvertently created the most cost-effective tactical strike weapon in the history of land warfare. The defense industry did not do this. Hobbyists did. And when Ukraine needed to produce hundreds of thousands of them in weeks, the manufacturing base was already there, in hobby shops and commercial drone companies, in the same global supply chain that serves racing pilots on 6 continents. The FPV Kamikaze is the AK-47 of drone warfare. Not the most capable weapon. Not the most sophisticated. But available, producible, adaptable, and cheap enough to be everywhere simultaneously. In mass warfare, availability wins. Ukraine has deployed these at a ratio of roughly 1,000 to 1 against Switchblades. Not because the Switchblade is inferior, it is superior in every technical dimension. But at $300 against $6,000, the economics allow a scale of deployment that no precision system can match. That ratio, 1,000 FPV Kamikazes for every 1 Switchblade, is the sentence that explains why defense procurement offices around the world are currently rethinking everything they thought they knew about tactical strike weapons. The full FPV Kamikaze data card is available at the link in the description. Download it, keep it, and we will see you on the next one.